Greetings and welcome to the Pure Report. I'm your host, Rob Ludeman, and it is time to bring the orange. And we are now on episode 5 of the 15 architectural decisions. Thank you so much for watching, for listening. We're having a great time rolling through these, as always, with Andrew Miller, with JD Wallace, and we're going to be touching on the next 3 here with security. We're going to be diving into metadata, which we've referred to in a couple episodes already. So a little bit more meat for everybody on the metadata side. And then going into the notion of install, repair, upgrade, basically, let's call it serviceability. That's probably the word that I would have used a long time ago in my server days. That was one of the illities that we would always talk about. And so, yes, the illities. We'll get into the illities. So let us dive right in and go into security. Super important, obviously, right? We care about cyber. We care about preventing intrusions, and certainly we go back to the history of the architectural decisions. Security was, of course, one of those things that we had to account for. Where do we start?
Actually, Rob, if I'd known you were going to say bring the orange, I would have done a spray tan this last weekend. I'm sorry I didn't, but I'll make sure to do it next time.
It's reflecting off
me.
No,
I'm just talking about me. I'm totally talking about me. Nothing to do with the color palette.
Well, we've had the sun out here more in California lately, so I'm benefiting from that. JD's from Seattle. There's not going to be any sun going there.
So security, all the data, all the time was sometimes the tagline. This kind of thing talks about things like encryption, rapid data locking, but maybe let's just start with the encryption piece, if that's all right. So when we started out from a Pure standpoint, there was I remember actually with other products that I worked with, you could buy an encryption license and you would decide if you wanted to encrypt the data because there was overhead with that kind of thing. So there was a philosophy. There's a philosophy as well as some technical pieces of, hey, if encryption is a good thing, it should be on all the time. Now let's be very real. Sometimes encryption at a storage layer or a data at rest layer was an auditing checkbox thing. Like, is your data encrypted at rest? And what is that actually protecting against? Well, it's not protecting against penetration further up the stack if someone's getting into the web server layer, the application layer. But there are scenarios where it can actually provide value. And it does, frankly, very much matter from an auditing standpoint. So it's a little bit of audit piece, but the technology piece of it too. So we said with Pure, we are going to encrypt all the data all the time. You can't turn encryption off. And the way that we're going to help deal with the drawback, which classically was when you turn encryption on, you had a performance drop on the system because there's overhead on the CPU.
A lot of math involved.
Yeah.
It's got to write data differently. We actually said, hey, we can actually pair up how we do encryption with how Flash wants to be written to. That's a theme we've hit on before. Well, Flash actually likes data to be randomized and spread out all over the place. If you want a really good method of randomizing data, encrypt it.
Yep.
So there's this really nice synergy of those two things put together to allow us to have all encryption all the time without then the customers would say like, oh, what's the performance impact? Well, there isn't. Not just because you can't turn it off, but also because we actually leverage it in something that we'd have to do otherwise as far as how we should write to Flash.
Going along that theme of turning a perceived weakness into an asset. That's pretty powerful. Yeah, when we talked about security in terms of the foundational decisions, we've done so much more since then. We talked about in the last episode, safe mode. There's a lot we've done along these lines. But in those foundational years, it was all about how do I protect the data? These are... And many times we use the term crown jewels of a business. How do we protect these crown jewels? And it's about making sure everything's encrypted, but it's also about how we manage those encryption keys, right? And once you've encrypted something, you need to be able to decrypt it. You need keys to do that.
You
need to do that real time on a real time storage device. So where do you keep those? And most arrays of the time kept them in memory somewhere in the controller. Right.
Or maybe in an external key management system that was really hard to set up. It took a lot of maintenance.
It's one more thing to manage. That's another moving part, right?
Yeah. And so that introduces some of its own problems. Now, what happens? We talked earlier about how a big part of our design is that stateless architecture. Well, that key is certainly a very important piece of state, isn't it? And if I'm keeping that in the controller, I erode some of that value. And so we made the decision to actually take those keys and spread them across the drives themselves. That unlocked a couple of powerful benefits. What were some of those, Andrew?
So you didn't have to think about, so from a performance standpoint, You now aren't throttled in a certain spot, hopefully, kind of thing of reading those. There's also the piece of, I alluded briefly to key management servers. So sometimes you would actually have to say, do I have keys inside the system? Is it secure? Are they rotated? By actually pushing it down there, even as we changed out the controllers, we're not going to lose access to the keys because they're stored down in the shelf. Now, you do still have to think about, security scenarios, and we actually have some really deep papers and actually a whole security incident response team, PSIRT, I think, internally,
Yes.
that actually helps when people need to go deep with this. But also just the simplicity, because, again, we're a little bit in the Wayback Machine. If you want to turn an encryption, you'd have to think about key rotation. You have to think about a key server. There were all these extra things that were sometimes the reason why people would say, like, oh, there's the performance problem, there's the simplicity issue. If I don't need encryption, I'm not going to turn it on. Versus unless you don't, the encryption is going to be on all the time because there's no actual extra overhead for you to do so.
Which led to what? Tiered environments, treating data differently depending on how you perceived it, because you wanted to avoid these different problems.
There were also scenarios, though, where that simplicity and spreading the keys across the shelves, actually writing it with the data, co-locating with the metadata, et cetera, it actually led to scenarios where for some customers in, I don't know, shall we say hostile environments, actually had a little bit of challenge with that.
Yeah. So again, this is an area where maybe a perceived weakness was an asset. The weakness being having easy to access and destroy keys.
Yeah.
There were some agencies, we might say,
Organizations. Yes.
who liked the ability to go in and be able to instantly destroy keys. Because on Flash, how do you truly delete data? It's very difficult. The functional way of just deleting data is to remove the encryption keys.
Yeah.
And the data is not accessible anymore. And so there's a great story where our founder Kaz had one of these customers tell them this story. Well, hey, I actually see this as a weakness because now I can't instantly delete my
competitor has
Invaded my data center.
data center and
so
data.
So Kaz went off and said, well, I can fix that problem. And that bore out rapid data locking. So now
RDL.
we split the key, put part of the key on an external. At the time, it was a card. Now it's actually a little USB key
In the back of the array.
But so it's taken various physical forms over time. But now, literally, I want to destroy those keys. I go pull that physical device, break it, shred it, whatever I need to do,
Yank the power.
and effectively, my data's gone.
Just like that.
There's even an interesting, this for me, some where this clicked when I joined Pure, because some in a previous life you can find on LinkedIn, where someone who's now, I want to say, the head of security at Box, walked through like how on Flash you basically can't ever know that you truly delete data. So the only way that you can ever do it in any way, and I've actually, one of the patents I'm fortunate to have is actually around this, that they actually could throw away the encryption keys like in a multi-tenant environment or otherwise. So if folks are listening to this, there may be something that you want to go pursue. Think about how, if you're doing data removal in Flash, it really should be based around throwing away the encryption keys irretrievably. I don't know if that's going to lead you to maybe audit some of your other internal security processes. One of the other benefits that came out of here, so kind of leaving a little bit before we go forward, is a lot of times, especially with some of these same agencies that had very high requirements around data security, there would be the idea of non-returnable drives. So you'd buy support for the array with, that includes software updates. And of course, Pure does this better with Evergreen Forever, including controllers, et cetera, or Evergreen One. But you might say, I can't send you any drives back. However, because of how we do the key rotation, even when you remove a drive, if you take a SSD in the past, direct flash module out today, you literally cannot access any of the data on the drive. And that's separate from us having a custom key value store or file system, how we write to the drive. It's actually that the keys have rotated inside the array, so the data on that individual system is not on that individual module is not accessible anymore. And that means that what I've seen is, especially working with federal or highly regulated, et cetera, we see a dramatically lower number of customers actually have to purchase the non-returnable drive option. Different vendors have different terms for this. But especially in a Flash world, where that's a relatively expensive module, that can have a real, for Pure, competitive advantage. It can have a real cost advantage to a customer. Now, your security teams have to validate this and say, like we agree with the promises you're making. But that piece of how we did encryption and rotating keys, even when you pull a module out, can have real cost impacts, because now you could return those modules and not worry about the data on them being leaked.
Yep.
Yeah, and we are fond in this series of doing callbacks, right? A lot of what I'm hearing here is relative to simplicity that we covered in the first, right? These are definitely things that dovetail with simplicity. I remember when I first came here and you'd go into a customer situation and invariably you always get to that, oh, what security do you provide on your arrays? And it was much easier to not get into these complicated discussions around different tiering profiles of doing security and just say, we encrypt all data at rest.
AES 256. I probably should have said that sooner.
It's AES 256 and
Well, it's about eliminating to the extent we can unnecessary decisions.
Yeah,
correct.
There was
same principle.
there was a feeling in the industry at the time where there were massive trade-offs between do I encrypt and do I gain the security of having the encryption at the cost of the performance impact, or do I gain the performance and understand that my data is going to be at some level of risk because it's not encrypted? And we said, hey, we're going to solve the problem a different way. We're actually going to use encryption as an asset, make it part of the underlying architecture, remove that option. It's just always on.
yeah. But it was very familiar, right? For me, coming from server world, where that was a conversation that took much longer because we knew the overheads, right? You want to encrypt. Okay, cool. We know we're gonna have degradation at this rate. So where and how do you want to go and deploy? And so for me and for others coming in here, it was a much easier, really quick conversation to just go right to, yeah, we got you. We're good. Don't worry about all that complexity.
If folks are listening and thinking like, hey, there should be deeper things around device data encryption keys, array data encryption keys, and actually how they're kind of nested inside each other, we have good papers for that. They are usually under NDA because this is a level of IP, but it's stuff that we do share so that you can validate some of what we're saying. Being real, depending on if you're a security engineer listening, you might have been like, wow, that was really high level. But trying to give the right amount of
It's
depth
also a
for
callback,
podcast.
and I'll do a shout out to Mayank, who you both know. When Mayank joined he's a product manager on the Array team now, but when he joined, he sat across from me in Mountain View, and I want to say the first 6 to 9 months that he worked, he just sat and he wrote all the detailed specs and papers around security. Because nobody had really done it at that level of depth. I mean, there were different bits and pieces there, but he basically went, and some of the things that you can still find on the web relative to security are things that he wrote for us back in 2017, 2018, which was kind of cool.
Our federal account teams appreciate that effort.
Yes, indeed. Indeed.
Because if we don't have that, they get asked very kindly, politely, maybe in a different way.
Right.
You know?
That's right.
There is a little bit of an elephant in the room here of security is such a bigger space than when we started out and we know some of the history.
Yep.
And we even discussed how far do we go with pulling this forward. So maybe to give a kind of a Cliff's Notes version for people that are listening. So insert the commentary about safe mode. That plays into a security philosophy and even removing some decisions that you have to make because you can turn this on array-wide or automatically, et cetera. We did things as far as there's been a whole cyber resilience practice at Pure. Some of that was originally modern data protection, turned into cyber resilience. There's partnerships there with companies like Superna and Veeam and Rubrik and Commvault. And I'm not trying to leave anybody out of our great partners there. There's a whole aspect there that links into security. There's pieces inside Pure One that go more toward helping you see having better visibility around either. It's literally called a security assessment. Pull up Pure One if you're a customer. You can see it right now. You can actually see kind of the security level of your arrays and the different features and capabilities and lockdown. You can see one that's called data protection assessment. It's how much you're using snapshots and replication and safe mode, the different capabilities built into the array. And then there's even features. We could talk about secure multi-tenancy and how the secure application workspaces that integrates up into Portworx. So there's this whole wealth here built on this philosophy of we should make the array secure. We should make it simple and try and remove decision points. And now I'm going to thinking sometimes I can close my eyes and see the security vendor worksheet that shows 10,000 different vendors in this space. This is a huge space.
Well, and you didn't even go down the BCDR route too, where we didn't even hit on the different ways that we replicate data, which is data protection, but
layered resiliency architecture.
The layered resiliency, right? So, and I think the net, and we've done this on other episodes, is we're focusing on the core decisions, right? And we're elaborating on the why, what it is, and the impact for users and customers, but we haven't just sat still.
There's
with
such a
those
rich
initial feature. We've evolved, right?
Such a rich set of current capabilities that are industry leading as far as what they can do.
Yeah.
We don't do everything. You need partners here, but where we still play in this space, we have some really new things to offer that link back to that core philosophy.
We've come a long way with the partners too that we've evolved into. When we started, it was largely just the backup partners, but they also evolved into more focus around security, around resilience, cyber. And now we're working with a broad range. And you certainly in this space, there's just too many things to worry about in cyber to go do it yourself. And really, when you get down to it, we are the infrastructure and we need those partners. And so those strong relationships, plus some of the new ones we brought online, super excited. You can go back to the audio Pure Report and check out episodes that we've done around cyber back in October of 2024.
Jason
a recent
and Alex
one
just recently.
with one of our partners, with Jason and Alex Esterberg. So definitely can check those out. But security, always pertinent, always relevant. But I want to get us into the next topic for this one, which is metadata. Now, we touched on metadata in some other episodes, and it's really interesting, but maybe controversial. I'd say that our approach with metadata enables a lot of the things that we've been talking about and is a really, really distinct advantage. Maybe not quite up there with what we'll do in the capstone episode around proactive support and Pure One and Evergreen, but really sneaky under the covers when you look at what our metadata does to enable so much functionality, but one of the most intelligent design choices that we probably could have made.
Yeah, and I think with metadata, the core idea is that all of these deeper functions, these storage functions that we've been talking about, the cloning, the snapshots, the deduplication, all of it, RAID,
Yeah. Mm-hmm.
all of these activities, they were necessary to build the product that we built and the capabilities that it has. But every time you implement one of those capabilities, you're generating more metadata.
Mm-hmm.
Well, I need to describe how I changed the data, and I need to hold on to that state somewhere so that I can eventually unwind that and give the customer back what they asked for. And so from the beginning, I think we understood that metadata was going to be a key challenge to solve if these systems were going to be really not only performant, but predictable in how they behaved. And so we had to address that with some core thoughts around how we treat that metadata. Many systems of the time were trying to separate out metadata and treat it differently, building very large caches. There were a lot of what we called hybrid storage systems of the time that mixed SSDs and hard drives. Well, let's segregate out the metadata and let's just put that in the flash portion. Even today, there are some architectures that put metadata in SLC media, very high performance flash, very costly flash.
SCM as well.
SCM.
Also.
And, as we start to do that, we're making more and more architectural changes that move it away from the core things that we've built. And so at Pure, we said, look, metadata is going to be written right alongside the data. We've already built all of these efficiencies, the compression, these resiliency paradigms. And so having that metadata and that data written together is going to be really important in how we maintain those. Now, we had a little bit of an advantage because everything was flash.
Yes.
Right. So no matter where we put it, it was always going to be in a high performance layer.
The core there is that when we looked at this, we decided, and this goes to even a little bit of, I think I heard the phrase of like Kaz came from a perspective where he knew all the problems in the storage industry. And then the other co-founder at the time, David Hayes, I think the way that the venture capitalist described him, Mike Spicer with Sutter Hills, was he knew how to fix any problem. So when someone who knows all the problems, and if you say, I want to have all these capabilities that you just listed off, JD, RAID and snapshots and duplication, all this, you actually need an engine under the covers that isn't a classic storage array engine. You're not thinking about how RAID works classically. So Pure at core, when I'm trying to be a little bit controversial and make people think a little bit and say, Pure's not actually a storage array. Pure is actually a key value store, and I've borrowed that from multiple folks at Pure. So this is an original. Pure is literally a key value store. It's a database. It's a database for your data, and the ways that you talk to it are not SQL or other application protocols, but actually storage protocols. Now there's some interesting thought experiments there about how you could potentially actually expose other protocols out of as external ways to access a metadata engine like that. We've chosen to focus on block and object and file protocols, but the underlying approach doesn't rely on that. So if you say, okay, it's not actually a RAID type, where we're now allocating out. We actually have this database right in the middle, this metadata database or key value store. We have to make that super performant. And this is the focus on and around enabling all of those upstack capabilities. There's also, like you referred to, sometimes like, hey, where would the metadata live? Would it live on flash? Would it live on disk? How would it overflow? And even, again, a little bit in the Wayback Machine, there were some systems at the time that said all the metadata has to be in DRAM. That makes a lot of sense because it has to be super high performance kind of thing. However, what does that do? Well, that caps the size of your metadata table based on the amount of DRAM that you have in the system.
DRAM's expensive.
It's expensive.
Hello.
And it might be a little bit disruptive when you need to add it. I don't know, kind of thing. So we actually said, okay, we are going to have metadata living in DRAM, but it can actually live and float between DRAM and between the flash. And it can be adaptive. There's even some stuff about an adaptive metadata fabric where you talk about versus fixed metadata fabrics kind of thing. Because there were even some systems at the time, because they relied on their metadata living in DRAM, they had to do redundant UPSs as part of the system because if the system lost power. We talked about this before. If you yanked the power plugs or the UPSs went offline, you would actually have metadata corruption. That's a really bad thing. So there's this level of even saying, hey, we can actually have metadata live in DRAM. We can have it live in flash. And there's a scalability aspect that when we started this out, SSDs were tiny compared to the 150 terabyte DFMs we're talking about today. That we're, keep me honest here, JD, we're shipping 150s. We are shipping 150s. Yeah. So think about what SSDs were 10 or 15 years ago and that explosion. So there's this piece of, hey, we're planning for the future. I don't know that anyone 15 years ago thought we'd have 150 terabyte DFMs because the arrays were nowhere even near that. But there was this engine architectural approach for incredible scalability.
And you know what? Your metadata pointer was off just a little bit before that. John Hayes. Founder, yeah. So I'm going to hit you in real time just so we don't have to go back and do an edit. But wow, we're older guys, right? So, metadata pointers in our heads don't always work, properly on that. But no, again, that's another one of those, how much did we see the light initially for the future and the scale? I don't know. Maybe they didn't anticipate the extent to which things would go to get to those capacities. But isn't it great? Isn't it great that you designed from the beginning so that you could hit the levels of scale that we're doing right now and the capacities that we're doing right now and still have that architecture continue to work and without a major overhaul, right? And again, I'll point to the capstone when we're get to Pure One and Evergreen, right? That's really what it's all about with that scale and that expandability and without doing massive redesigns of things that are super disruptive in customer environments.
Well, one last kind of thought on that.
Yeah.
You talked a lot about kind of how we use DRAM and the efficiency of that. The really, in my view, the really important part there is by making those architectural changes, we've decoupled the DRAM from the capacity of the system.
Yep.
So yes,
Core
it's true.
principle.
We have 150 terabyte DFMs now, but if we hadn't done the work to decouple that from the metadata impact to DRAM,
Could never scale.
we would have had systems so large and so expensive from a memory perspective, they wouldn't be practicable.
Yeah.
Maybe I'll do a last thought here and then I'll let you migrate. But there's even this interesting thought experiment of how we can even go from I'm going to do a little bit of armchair analyst, but there's a technical analysis part of this too, about the cost of capital around when Pure was starting. And you actually look at this from an economic standpoint. Pure was in stealth for a certain amount of time, and then we were actually investing more in core engineering. And there was a bet there that we will invest in engineering and it will have this long-term trade-off. We were able to fundamentally do that, partly because of the vision from a founder standpoint kind of thing, but also is enabled at a secular market standpoint around the cost of capital. So sometimes I'll have this fun thought experiment with folks and say like, hey, even if someone wanted to do this level of 3, 5, 7, 8, 10 years, level of engineering, because we did some of it after we came after stealth and we keep investing here. I don't know that they could even pull it off. Because look at the cost of capital today. So this is pulling a little bit of armchair economics analysis into it, but that plays into some durable long-term advantage because we had the environment to be able to make this kind of an investment.
There's still a choice over time to spend a percentage of revenue on R&D, though, right? So yes, cost of capital has changed over time, but when we go and compare to our competitors about what we believe our innovation needs to be and the amount that we spend,
When you're a startup,
right?
you're in burn rate
Right,
period.
you're in burn rate,
And
but now we still look at that those double-digit
Same
investment
philosophy.
rates. It's the same philosophy. We still
Yeah.
think there are great things that we can go and design for our customers and for our partners to take advantage of selling, and it's super cool that we continue to do that.
or somewhere stats that I saw on some internal stuff, but you could actually just find this by asking Perplexity or ChatGPT, your favorite. Just say, compare pure percentage rate of R&D investment to our nearest competitors by percentage, and you'll find some dramatically different numbers. I'm not going to say them because I'm not trying to go there
We'll let people
competitively.
go off. We'll make
but
that a CTA.
It takes one prompt in your favorite chatbot of choice.
Yeah, make that a CTA. Okay, let's close this one. And this one will be a little more brief than the couple that we've just dived into, because security metadata, really important to cover it at levels of depth. But let's go into what I have listed here: install, repair, upgrade. Some of the older documentation talks about a DIY approach to the hardware, which has some potential interesting pitfalls, right? If you go to really
Pros and cons.
pros and cons to go down that, but effectively it comes back to making it easier for customers to do things without disruption. But hit the install, repair, upgrade. I know in a prior episode as well we hit the installation instructions, right, on a
Tent card.
on a
Business
tent card, right, on a business card. Like, that is a prime example of how easy it is to get the array up and running and dealing with day 0, day 1 kind of problems. But let's hit this one.
Yeah, I guess as graybeard of storage here in the room, I'll talk about my experience.
We'll have to fight over that title later.
This is a true story.
Yeah.
I remember preparing to upgrade the firmware on a storage array I managed earlier in my career, and every component had its own firmware. So there wasn't a single package. It was all of these different packages that had to be installed. Because of the complexity, they had to be installed by support. Of course, they charged me for that privilege of coming installing those. And I had to have a 2-week ahead of time assessment with an on-site engineer to make sure I was even ready for them to come back and do that installation. So cost, time, energy,
Planning,
complexity.
scheduling.
But the classic things that plague productivity.
Yeah. And so you mentioned DIY storage. I think that's kind of an intellectual concept to some level.
Yeah, I wanted to get it out there.
When we think about the complexity I just described, like, oh man, how nice would it be to upgrade my storage array the same way we didn't have iPhones back in the day.
Yeah.
But the same way I would update my iPhone today, right?
Mm-hmm.
Have that single click button, do that installation upgrade. And so I think that was kind of what we were thinking is we want that experience doesn't have to be that complex. We can solve that in software.
There's also, this is when I was on the partner side, you would have classically the term resident. You'd have someone come in, and it wasn't just resident for like migration, going back to all the different disk groups that they have to set up and map out the application. So there'd be all this setup before you'd even start migrating the data. And it might be days would be low, weeks would be normal, maybe to months. You just have basically a paid professional service person come in and start to map all this stuff out. So even though, now I'm going to embrace a little bit of the other side, we do have professional installation of Pure arrays today. And that is as much for the liability and question of someone going into your data center and doing physical things. Let's just be very real about that reality kind of thing. But the core simplicity of it is still there. It's incredibly fast to set up a Pure array. The number of cables you need, the number of plant you need. If you're doing a proof of concept with Pure, even a hosted proof of concept, we have a great test drive team that helps with that kind of stuff. This then led into even the approach that we took classically with upgrading the arrays. And I remember this because we used to sell actually for blocks, for infrastructure blocks that we used to work with that had one letter in front of them. We'd actually sell services around quarterly upgrades or coming in doing it. And when Pure started to say, hey, we'll have our support engineers do this for you as a white glove service with pre-checks, and they'll walk through it all and it'll be non-disruptive. And that's even now turned into even further philosophy of self-service upgrades. You can actually drive this out of Pure 1 today. So this piece of there's pieces here about DIY. And now I'm thinking like I'm going to Home Depot or Lowe's or Ace or your hardware store of choice, kind of thing. But this underlying piece of we want to simplify anything related to serviceability, install, repair, upgrade. And there's different facets of how that's played out over the years. But especially whether you're comparative back then or you're comparative today, dramatically simpler.
Well, and my marketing hat goes on, right? Because I'm seeing what you had on your iPad there. And when I started, the core value props, right? The key messaging that we talked about fit into 3 words that started with the letter E.
Yeah.
And I still love these, and I still will go back to them from time to time in discussions, even though we're not actively using them. The first one was effortless, and that's just what we're hitting now with the ease of installation and the ease of upgrading. The next one was efficiency. Look at all the topics that we've hit over the course of this series. It's all been around efficiency and the things, JD, you just hit around cost and around time and around complexity. And then the third one, this will be a segue to episode 6, join in, evergreen, right? And how evergreen was a foundational philosophy for how we design and architect it, and really getting into how non-disruptive upgrades for everything. But I always loved the 3 E's. The 3 E's were really easy to go around and write a blog, to go do messaging around. But we're hitting on the one that was effortless, which was not just about install. People would hone in on the install. That was the one that was really easy for them to understand. Oh, the array showed up. Cool, I'm going to do this. Wow, it didn't take so long. That's so great. But then we get into the run, right? You get the build, you get to the run. I remember talking to customers early on, like, what's it like to run a Pure Array? And they go, I don't know. I don't actually do a lot with it. Right? We check it every once in a while. Okay, cool. What about the upgrade part of doing that? Oh, yeah. Well, and at that time, your SEs came in. They told us what they were going to do. They upgraded capacity. They upgraded controllers. They did a purity upgrade. And they did it non-disruptive, and we kept going. So those things, super powerful and still the same.
I'm surprised we haven't brought this concept up yet. Day 0, day 1, day 2.
I hit it a little bit ago, but yeah, we didn't go into detail.
That's how you and I actually started out. And there's a Lightboard video where I talk about that with FlashStack, but it's the day 0, so much less planning to set up. We've hit on that. Like let's pull RAID configuration. That's a piece of day 0 you're not planning. Day 1, you're setting it up. Day 2, how much time do you actually spend running it? All of those, if you think about your life in that way, if you're listening into this, dramatically reduce as far as the amount of time that you have to spend.
Yep. Good one. Anything else we need to go in and add on that one, JD?
You know, what I would add is I still think there's a little bit more work to do here. So
Okay.
I still think, culturally speaking, we have a hesitancy to roll out software updates more quickly.
Mhm.
And I really encourage our audience to rethink some of their thoughts around that, because
You mean, when you mean rollout, you mean, sorry to jump in, you mean people to adopt more of the
newer,
more modern, latest and greatest,
exactly.
Newer
you know,
versions of
purity
code.
versions. Okay.
As we talk about security vulnerabilities, that's a
huge one.
bigger problem than it's ever been.
Mhm.
And one of your best mitigation strategies against that is to make sure you've got up-to-date software,
Latest and greatest.
latest and greatest, that's eliminating as many of those potential vulnerabilities as possible. And just from a value perspective, we're continually rolling out new capabilities. We've made the upgrade process as simple as we possibly can. And we have a great trajectory for customers that are using self-service upgrade, but I think we can continue to do better. So that's my call to action for this one.
It's a great call to action, and one that we're really focusing on this year, this calendar year as well, mainly for that last point. The security one, that's bottom line. You
External
got to
driver.
stay on the latest to do that. But think about the capabilities of a Fusion or a file on FlashArray, the safe mode, and the other features, right? You got to be on the latest to get to those, and then it will change how you operate for good reasons.
Come for the performance, stay for the simplicity.
Here we go. That's a good way to end it. Well, thank you everybody for tuning into this episode 5. Nicely done, JD. Nicely done, Andrew. We covered some dense areas there, but I think at the right altitude for people to really get an understanding and a glimpse into why we made the choices around security, around metadata, and around the install and the repair and the upgrade. And that was a fun jag right there at the end. So thank you for watching this episode and sticking with us in this series. I hope it continues to be valuable. Share with friend, tell a colleague, enjoy the new video format, and we will wrap for Pure Storage, my good buddy Andrew Miller, JD Wallace. This is Rob Ludeman saying, don't look back. Something might be gaining on you.